Okay, so let's review what we have here. If we've got x squared, if it's positive, it'll look like this. And if it's negative, it'll look like this. And so what we're going to do is use these graphs to describe all even degree polynomials. So x to the fourth, x to the sixth, x to the eighth, they all are going to end the way x squared ends. So x squared ends up and up so it's going to end up on the left, up on the right when x squared is positive. When x squared is negative, it ends up going down, down. So down on the left, down on the right. And the same thing happens for any even degree polynomial. For odd degree polynomials, so if it's positive on an odd degree polynomial, then it's going to end down, up. Down on the left, up on the right. If it's a negative odd polynomial, then it ends up on the left, down on the right. So that's what happens when it's a negative and odd degree polynomial. So take a second and pause the video and write down what you see here. So it's the same setup every single time we describe the end behavior of a function. You're always going to say that the y value approaches something as the x value goes negative, and the y value approaches something as the x value goes positive. And that's what I wrote for every single problem. We're going to describe what the y value does as x goes negative and as x goes positive. So what we have here is x is approaching negative infinity. So that means the furthest left part of the graph, or how it ends on the left. Here, x is approaching positive infinity. So we're asking what is happening on the extreme right of the graph, so where that graph ends on the right. Now what we need to do is first look at the degree of the polynomial. So here I have degree 2. And it's a positive 1 in front of the function. So that means it's going to look like this, where it's positive and it's even. So it's going to end going up and up. So it goes up on the left, so positive infinity on the left, and it goes up on the right, so positive infinity on the right. We know it looks like that. Well, here I have degree 3, because I've got x squared and x, which add up to degree 3. So that means it's going to end up like one of these. Now the number in front is a positive 1, so that means it's going to end like this, because it's positive and it's odd. So it's going to end down on the left, so we're going to put negative infinity there. And it ends up on the right, so we put positive infinity there. Here, I've got degree 3 again. I've got squared and 1, which makes degree 3 when you add the exponents. And there is a negative 4 in front. So I've got degree 3 and it's negative, so it ends like this one. So on the left, when x goes negative, the y's go positive to positive infinity. On the right side, as x's go positive, the y values go negative, negative infinity. For this one, our degree is 4. So we've got 3 plus 1 is degree 4. And all even exponents end like the squared function does. This leading coefficient is negative, so we're looking at this graph. It's going to end going down, down. So in this form, we would say the function goes down when x goes negative, so on the left. The function goes down as x goes positive, so on the right. Here my degree would be x squared, and then x squared times 2, so x to the 4th. So this is degree 6. 2 plus 2 plus 2. Degree 6, which means it has the same end behavior as my x squared function. And the leading coefficient is a positive 3, so it's going to end like this one, up, up. It's going to go up, up. So it's going up on the left, up on the right. So positive infinity, positive infinity. Here I've got degree 3, because 1 plus 1 plus 1 is degree 3. And the leading coefficient is an invisible positive 1, so it is like the positive x cubed function, or it is a positive x cubed function. And on the left, it goes down, so negative infinity. And on the right, it goes up, positive infinity. On the next example, we are going to follow these rules for sketching polynomials. First, we're going to find all the zeros and the intercepts and plot them on the graph. Then we're going to determine whether those zeros touch or cross on the x-axis. Then we're going to find the y-intercept and plot that point. We're going to find the end behavior, and then we're going to connect the dots and make that sketch. So let's start by finding our x-intercepts. So here, x is 0. Here, x is 3. This x equals 0, let's put it on the x-axis. And x equals 3, let's put that on the x-axis. This x equals 0 has multiplicity 2, which means it's going to touch there because the multiplicity is even. This has multiplicity 1, an exponent of 1, so it is going to cross the x-axis there because it's an odd multiplicity. Let's also find our y-intercept. Our y-intercept we find by plugging 0 into the function. In this case, we get 0 times negative 3, which is 0. So 0, 0 is my x-intercept, which I already have graphed, so I don't need to graph it. And then we need to think about the end behavior. So what kind of degree is this? This is a degree 3 polynomial because you have 2 plus 1, or you can add your multiplicities together to figure out your degree. And it's a positive leading coefficient. There's an invisible 1 in front, so that means it's going to end like a positive cubic function. So it's going to end down and up. So I'm going to go over here, and I'm going to make sure it goes down from that point, and it goes up from that point. So I get that from my degree. And then I have to figure out how to connect them here. And so what we said was at 0, it touches, and at 3, it crosses. So that means as we go left to right, as we touch 0, it just touches and bounces back. It bounces back down. And then it's going to swoop back up and cross through the 3. Crosses through the x value of 3 to go up. So that is a sketch of your graph, a rough sketch. So here I set this equal to 0, and I get negative 1, negative 1. Here I set that equal to 0, and I get 3. So let's plot that on the x-axis, negative 1 and 3. Then this 1 has a multiplicity of 2 because of the exponent of 2, which means it's going to touch at negative 1. This 3 has a multiplicity of 1, which means it's going to cross there. Then let's find our y-intercept. We need to plug in 0 for that. And so here I'm going to get 1 squared times negative 3, so negative 3. So at 0, I'm going to go down 3, plot the y-intercept. And then I need to look at the degree. So you can add your multiplicities, it's degree 3, or you can add your exponents, it's up to you, degree 3. And the number in front is positive, it's an invisible positive 1, so that means it's going to be a positive cubic function. So that means it's going to end down on the left and up on the right. So we put that on the graph. And then we see at negative 1, it just touches. And at 3, it crosses through. So at negative 1, it touches, it bounces back, connects to that y-axis, and then crosses through on the 3. So it goes up, touches, bounces down to get the y-intercept, and then crosses through on the 3. So here we have x equals 0, which would be multiplicity 2, which means it touches. Here we have 3, which would be multiplicity 1, and cross. Here I have negative 4, multiplicity 1, cross. So let's plot those 3 x-intercepts. So we've got 0, we've got 3, we've got negative 4. And then I can find my y-intercept by plugging in 0. But I already know. I already have a point on the y. So I already know it's going to be 0, 0. But if you don't know that, you can plug 0 in. And then Let's look for our degree. You can add your multiplicities together, we get degree 4, or add the exponents together, and you get degree 4, which means it's going to end like a parabola. And it's positive in front, so I know it's going to end up, up. So I can go ahead and put arrows up and up on the ends. And then I have to figure out how to connect them in the middle, so I look at my touch cross. Negative 4 crosses, so it's going to go through the x-axis. 0 touches, so it's going to touch at 0 and bounce back down. 3 crosses, so it's going to come back up and cross through at 3. So it makes a W looking shape. Here I'm going to get x equals 0, and here x equals negative 2. 0 has a multiplicity of 2 because of the squared. This has multiplicity 1, which means it's going to touch and cross. And let's plot those. So I've got a point at 0 and a point at negative 2. I don't need to look for my y-intercept because I already know it's crossing the y at 0. But I could figure it out by plugging 0 into the function. And then if I add my multiplicities, I get degree 3, which means it is cubic. And there's a negative 4 in front, so it's going to end up, down. So I can go ahead and make it go up and down on the ends. And I have to figure out how to connect them. So we've got it touching at 0 and crossing at negative 2. So it's going to cross through at negative 2, come up and touch 0, but bounce back down. So that is a rough sketch of that. And then here I get x equals 1, x equals negative 2. I've got multiplicity of 2 because of the exponent, multiplicity 2 because of the exponent, which means it's going to touch and touch. And then we can plot those. So I've got x at 1 and x at negative 2. And then I need to look for my y-intercept because I don't have anything crossing y yet. So we're going to plug 0 in for the x values, which gives me negative. When I do negative 1 squared, I get 1. When I have 2 squared, I get 4. So negative 4 is where it crosses the y-axis. It's my y-intercept at negative 4. And then I need to look at my degree. If I add my multiplicities, I get degree 4, which means it's going to end like a parabola. And there is a negative 1 in front, so it's going to end down, down. So I can go ahead and go down and down. And then we have to figure out how to connect the middle, and each of them just touches. So we, from left to right, go up, touch, bounce down, get the negative 4, up, touch, and go down on the right.